Hey guys, so this video is actually going to be a continuation of my last video, and what I want to do in this video is just primarily focus on the implementation. So what I wanted to do in this video was to just walk you through the implementation process of creating a linked list and determining if the linked list is cyclic or not. So let's get right into the code. Alright, so as you can see here, I have my project already created. I already have my application object here. But another thing I want to do is, first of all, create myself a class. Alright. Now, as I was talking about before, linked lists consist of nodes. So nodes are the foundation of a linked list. In order for a linked list to be constructed, there has to be nodes within it. So we're gonna first of all create an object of type node. Gonna finish. Alright, so we have our node class here, and as I stated in the previous video, nodes, they are consistent of two parts, which is data as well as a reference to the next node. So the first thing we want to do is create some properties for this node. So first thing we want to do is create a data member of type string. Public string data. Now this variable is going to hold the data that you pass into the node. Just like in my previous video, we were passing in letters A, B, C, D, etc. We want to make sure that this node takes in string data. Now what we also want to do is create a reference to the next node, and we can do that by creating ourselves a node object and naming it next. Now after we do this, we want to create a constructor, and this constructor is going to take in a string value, and this data is going to be data passed in by the user. So they are going to pass in whatever value they want into this constructor. And we also want to set the data member equal to the value passed in to this node object. We can do that like this. This dot data equals data. Alright. Now the only thing left to do is just to add the getter and setter methods for the data members that we've declared here. Now we can do that like this. We can just go down here, right click, go to source, and down here we can make our way to generate getters and setters. Go up here, we can select all. We're going to select both of these data members. Press OK. And as you see here, we have the getter and setter methods for each of the data members that we've created. Alright. So what I want to do next is actually create the linked list now. So I'm going to right click, new, class, and we're going to name this class linked list. Alright. Now, in this linked list class, what we want to create first is a data member of node, and this node data member's name is going to be called head. Node head. Now, this data member is actually going to point to the beginning of the list. So basically, when this list is constructed, we want head to be the first node that's going to be created. And we can do that by creating ourselves a constructor. Public linked list. And then we can go head equals new node. And then we can just pass in the value head. All right, just gonna save this. Let me zoom this in for you guys. All right, so we have our class linked list. We have our data member node, named it head, and we have a linked list constructor here. So basically, when this linked list is constructed, we're gonna create a new node that begins at this node head. All right. So the next thing we want to do is create a method. Now this method is going to append elements to the end of the linked list, or append nodes to the end of the linked list. All right, so the first thing we want to do is go public and void append to end. All right, so this method, we're gonna take in a node. So we're gonna allow the user to pass in a node, and then this node is going to be added to the end of a linked list. So we want to go inside of this method, and we want to create another node. We're going to name this node current, and we want to set this current node equal to head. Now the reason we're setting this current node equal to head is because we're going to use this value to determine what place in the linked list that the node passed in needs to be added. And obviously, based on the name, it does need to be added to the end of the list. So we have to actually use this variable to check to see what position in the linked list that this node is going to be added to. All right. So the first thing we want to do, we want to create ourselves a while loop. While. Then inside this while loop, we're going to go while current.next is not equal to null. Now, basically what this while loop is doing, this while loop is actually checking to see if the next node is null or not. So basically what's happening is the current will be the current node that you're on, and this next will reference the next node after the current node. And we're just checking to see if there is another node after this current node. So while current.next is found, then we want to set current equal to current.next. So this while loop is going to continue and make its way through this current.next, and it's going to continue this loop as long as there's another node in the linked list. Right below the while loop, what we want to do is this: current dot next equals node. All right, so basically what's happening here is if current.next equals null, then we want the value that the user passed in to be added to the end of the list. So I mean, this method is pretty straightforward. And I hope you guys understand exactly what I'm doing here. Let me just go over the method one more time. So first of all, we have this method. It's called append to the end. So obviously we're going to be appending this node to the end of the linked list. After we do that, we create this node current and we set it equal to the head. So the current node is set to beginning of the list. All right. So after we do that, we want to check that the next node is found. Next node is found. And if the next node is found, then we want to set the current node, set current node equal to the next node. And basically what we're doing down here, we're pretty much saying if current.next equals null, then set that equal to the new node. So basically if it breaks out of this while loop, then that means that the current.next node is null. And basically from here we're just setting the node that's passed in to the end of the list. All right, so what I want to do next is create a method that's called is cyclic. Public Boolean is cyclic. Well, all right. So, as I said before in one of my previous videos, a way to determine if a linked list is cyclic or not is we need 2 pointers. Those 2 pointers need to start at the beginning of the list. All right, we need a slow pointer and we need a fast pointer. And I'm going to type that right now. So we need a node slow. We're going to set that equal to head, which is the beginning of the list. And we need a node fast, which is equal to the beginning of the list. All right, so what we want to do now is create another while loop. While, and inside this while loop, we're actually going to check to see if the next element of the slow or fast node is null or not, if it's found or not. So basically, this is how we want to implement this. While slow.next is not equal to null, and slow and fast, actually fast dot next is not equal to null, then we want to do something. All right, so basically what I'm doing, I'm checking the slow node here, and as it's making its way through the list, it's going to check if the next node is found or not. So if the next node in slow is found and the next node in fast is found, and the reason we have the 2 next here is because the fast is going to go 2 steps, it's going to make its way through the list 2 steps at a time, whereas the slow node will only make its way through the list 1 step at a time. So basically we're just going to check this conditional statement, put it in a while loop, and this is what we're going to do next. So basically if the slow.next is null is found and the fast.next.next is found, then what I want to do is set the slow equals to slow.next. And I want to set the fast equal to fast.next.next. All right. So I want to set the current slow node equal to the next slow node, and I want to set the current fast node equal to the next fast node, which will be moving 2 steps at a time. All right, so right after here, I want to add myself an if conditional statement, which is going to go if slow equals fast, then I want to do something. So the reason I'm doing this is because, do you remember what I was talking about in my last video? If the slow node points to the same node as the fast node, then the list contains a loop. So basically, if the slow node is equal to the fast node, then what I want to do is return true. And outside of this while loop, what I want to do is return false. So if the slow node never is equal to the fast node, or if the slow node or the fast node is null, then I want to return false. And that's it. Now what I want to do is go back to I want to save this first of all, then go back to my application object. And now I'm going to show you how to go about creating this linked list, adding nodes, and determining if it's cyclic or not. All right. So the first thing I want to do is create a linked list object. My list. I want to set that equal to new linked list. All right. So the first thing I want to do is I want to add a node to this linked list now. So I'm going to go my list dot append to end, and this is going to take a node object. New node. And then, as I said before, this node is going to take in a string. So I'm going to add a. All right. My list dot append new node, and I'm going to pass in b. To actually speed up this process, I'm just going to do some copy and pasting really quick. All right, A, B, C, D, E. So this is what this linked list looks like. A, B, C, D, E. All right, so this is what this linked list currently looks like. So we can just go sys out, and then we can call my list dot is cyclic. I'm going to save this, and this is going to determine if this is a cyclic list or not. So you're going to go up here, we're going to run the application as a Java application. Go down here. It's not, see? So this list is returning false, meaning that it is not cyclic. All right. So let's change this list around a little bit. Let's remove this. We want to change this list around and make it cyclic. So one way to do that would be to first of all create a node right here. Node cycle. We're going to name this cycle equals new node. What we want to do, we want to pass in C. That's what we want to do. We want to create a cycle at C. And we want to CLE. I'm going to pass in cycle here. Okay, and at the end of this list, we actually want E to point back to C. So to do that, we just go my list dot append cycle. Control S, save this, and we run this one more time, and let's see what we get. Run that, go down, we get true. So this list is cyclic. And that's pretty much it. That's the full implementation process that you would use in order to determine if a linked list is cyclic. You know, we first of all need this base class of node. We then have created ourselves a linked list with the appropriate methods, append to end, as well as is cyclic. And we have an application object which we actually use to test out the methods that we've created in our linked list. So that's pretty much it. If you have any questions, leave them in the comments below. Don't forget to like the video if you felt like you've learned something here. If you feel like you have a question that you want to be answered, let me know in the comments below. And until next time.